Hello everyone, here I am Vadel Sagar. Let us continue our discussion about the chapter number 10 regarding the light reflections and refractions. So, okay, as we've seen last about the regarding the reflections mainly and the formations of image due to the concave mirror and convex mirrors and also the laws of reflections and all about the basics and examples regarding the mirror formula. Yes, please kept in your mind the mirror formula is equal to 1 upon v plus 1 upon u is equal to 1 upon f. There at the end also we discuss about the magnification. That magnification is nothing but the ratio of the image height upon object height. If you don't have a height data, you can go with your object distance and image distance, which is u and v. At the for the mirror, the magnification is equal to h prime upon h, otherwise minus v by u. And also some of the discussion regarding the Cartesian sign conversions. Okay, let us go ahead for the example number 10.2. The very clear and easy example you can able to see that we are trying to see. And what is the question? First of all, at object 4 centimeter in a size, so that size is given, so the object height is given h. So here I can mention just for the read, and the h is equal to 4 is placed at 25 centimeters. So the object placed at the 25, so the u is equal to 25. Don't judge whether till that, don't judge is it minus or plus. So 25 match, make it in a front of the concave mirror. So concave mirror we are taking, and whose focal length is 15 centimeter. Now try to think about it. This f point is which is at the 15, and your object is placed at the 25. As per our judgment, this is the this f at the 15, then c point as should be, c point should be, tell me, 30 centimeter. As we know about, this is the always double. Or where is our object? 25. So I can make a judgment like f and c, our object should be in between. So that's why in a particular we have a 6 cases. Among them I am selecting this figure. So I am placing the particular this figure. Why here? That you should clear now. Okay, now regarding the rays diagram, from where to where rays goes and the image formation regarding things we will calculating, and according that we will understand also. So trying to see here now onwards, f is known, u is known, h is known. What we have to find, at what distance of mirror should be form image, so the v we have to find, and nature and size regarding information we should have to find at the end. Okay, h we know, u you know, f we know. It is a concave mirror, so the whatever the all the parameters which are come on the left of the pole, so the all of the distances which are minus as per our Cartesian sign conversions. So whatever the f is, focal length is given minus 15, image or object also at the this side, so this is whatever distance it has is the minus 20 minus 25. H is the, you are taking upward, so h is the plus 4. Okay, and now we are proceeding for the further calculations using the mirror formula. 1 upon v plus 1 upon u is equal to 1 upon f. What we have to find? 1 upon v. It means ultimately v we need to find, so 1 upon v is the as a main part. 1 upon f, 1 upon u is taking on this side. Respective numbers what we are already known, just we have to putting 1 upon f is replacing by the minus 15, as we know. 1 upon u, minus is already there, 1 upon u is minus 25, as we know. And just for the simple mathematics you have to do here, the minus minus plus become in the next steps. And just LCM is the 15 multiplied by 15 multiplied by 25, and respective sides of it will be plus 25 and 15. That simple maths you should know, because in the 10th class I cannot engaging to time these times to the LCM study. So just you are taking the manipulations of the further simplicity of this, and take inverse of whatever at the end answers you have to take, because it's the answer of the 1 upon v, and we have to find the v, so we have to take inverse, or it means reverse of it. So it will be going to be minus answer, because the minus is dominating here, as you can able to see in the first figure. Minus is still dominating. Okay, so this is going to be minus sign, minus 37.5. Now trying to understand what is our focal length, 15 centimeter. what is our r should be 30 centimeter, and what our v we get 37. It means your image formation should be beyond the C point. And this also in the, one of the case we already mentioned somewhere. And this not only 37, we have a minus 37. I can make a judgment of its image will form left of the pole. And you can, yes, here also we have, you can able to see our image is formed beyond C point also, which is at the 30 centimeter for the particular case, and our image form at the 37 with minus sign because of the left of the pole. So without doing any practical, without doing any ray diagram, we can able to make a judgment by the using just mirror formula. This is a very crucial point for us. The should be the place at the 37 degree 37.5 centimeter from the mirror. And yes, his image is also due to the original rays, so that's why it is a real image. Now what about the information regarding the size, shape and nature of the image? So this can be done by the using of the magnifications according criteria, that m is equal to h prime by h we know. If we don't have the height data, you can go with the distance data minus v by u. Yes, v we know, u you know, you can put the respective data here. You can go for the, yes, here they are proceeding for the different way, but you can go with the minus 37, minus minus going to be plus. You have how much you have 25. So 37 divided by 30 25 you can able to do, and you can get the answer same minus, which is 6 centimeter. So h prime, yes, but that is the magnification. M is equal to something, whatever digit you are getting, which is a magnification. But yes, here we have to find the height of the object. So ignore about this m. If you want to find h prime, h you know, h is given, v you know, u you know, you can go to the multiply h here, and other three parameters you know, fourth win, it's a very easily able to get this, and that is h prime is equal to minus 6. 6 is tells us about the height of the image, but the minus is tells us about the, it is forms down to the principal axis, as you can see in the figure diagram also. So I can make a judgment at the end, the image is inverted and it is enlarged also. How can I make a judgment of the enlargement? Because our image height at the earlier case is the 4 centimeter, here I have a 6 centimeter, so I can say 4 to going to be 6, so it is a enlarging. Okay, there is a one quick test is there, please read it and you can make answer at the comment section. Okay, here is the main task of this today's discussion is the refractions of light. What is exactly reflections? Because it's a major part of our chapter title also, light reflections and refractions. What is the mean of refraction now? Till that we are, whatever we discussed regarding the reflection, it means the returning of the light, particularly light, that we take as a reflections. But when our light is penetrate to the medium, it means suppose the sunlights are falling on the water levels, so it is not a mean that the light is always go touch to the water levels and go back. No, not in every cases and every medium the light is always written. Light can also penetrate through the mediums and it can go outside also. Okay, so when light is penetrate inside the medium, what happened? So light is bent. Don't see in this frame, I am talking about the general, what exactly the meaning of the refraction, that you have to clear now. So what is the mean of refraction where I am? So that is when light is entering in the any medium, the light is bent some, what the rays are following the path, that path is not keep when it change its medium to penetrating, man, change to the propagating inside the medium, it is banned or it is deviating from the original path, that the phenomena on the physics is called the refractions. Okay, so as you can see in the first diagrams, is the simplest diagram for the understanding of the sunrises are falling and the water levels are there. When it's entered into the water levels, it is band some, as you can see, band some angle. This is the one of the phenomena that occurs, and that is a sign of the refractions. You can see the break of the pencils. It is just visible phenomena. Actually, it is not break, but why? Because the light rays are bending, it looks like a break. Here also you can able to see when the light is passes through the same medium, it means air medium, it is go ahead in the what the path it has. But once it is passed inside the glass, yes, now medium density is changed because the air is not much dense but the glass is the much denser. So the light has to be changed the medium when it in between the path when it travel. So it is enter inside the medium and it is band, you can able to see banding is there. That is called reflections. Very easy. The light seems to travel along the path, straight path line, and when it travel to the transparent medium particularly, but once it is opaque, then it is always reflection happen. But when you start with this transparent medium, then the light is also traveling through the medium. And once it is travel through the medium, it is a deflecting. It means deviating its path according the density of the medium. Okay, so okay so this deviations is named as the reflections of the or refractions of the light. What happen when the light enters from the one transparent medium to the another transparent medium? The light is bending. Does it still move along the straight line? So those question answer you can easily answer now, because we are generally common way of understanding of the reflection we done it. Okay, now this is the simplest kind of diagram. From there, our students can understand very easily. This is the one particular rays from the sun we are taking, it's coming. And this is a particular one medium. I can understand, I can take as a air medium is there. And this is a second medium we have, which is I can take as a glass, you can take it as a water level or any. It means the medium is changing. That particular idea you have. So when the light is traveling through the one medium and it is fall at the some incident on the sun surface of the any medium, so that is called point of incident, and this is called incident ray. When it start to penetrating through the second medium, it is not keep on its same path, you can able to, it's deviating its path. That phenomena is named as the refractions. When this is a fundamental definition, so you can keep it on your notebook also. When a ray of light enters in oblique from the one transparent medium to the another transparent medium, this is also transparent medium, this is also transparent medium, it's change its velocity, due to which it gets a deviation from its original directions. That is the phenomena is called the refractions of light. Now you have a one question in your mind, why the lights is bent? That I can answer you, because when the light is change of medium, when it's propagating through the mediums, it's change its velocity. It is not keep on the velocity what it has. Generally the light has a velocity in air 3 lakh kilometer per second, 3 into 10 to the power 8 meter per second. That way also you can keep this speed. It is not keep when it travel through the water medium, glass medium, diamond medium, or any kind of other mediums. So this velocity is change. Once your velocity is changed, you are deviating from your path. That is the way on which this light is deviating. Okay, here we have a theta 1 angle, which is a normal. That's the basic things we already known about these things. So theta 1 is the angle of incident. In earlier cases we have some reflections case, so the light rays is here and we called as a theta 2 is called reflections angle. But here we have an inside, and always the angle measured from the normal, not from the surface. I am not talking about this angle, I am not talking about this angle between normal and that ray, angle between normal and this ray, angle between this and this ray. Okay, so this is called refraction angle. In the earlier case, the angle of incident and angle of reflection is always same, but the angle of incident and angle of refraction is never same, never same if the medium is different. Okay, this is the basic thing what you have to know. If I am taking the sine of the both angles and I am taking the ratio, I got a constant for the every case. If I am changing the light rays, because I can follow the light rays likewise also, that is theta 1 different, this theta 2 is going to be different than this. So this is constant every time I am getting. This is first finding by the Snell's, so this is named as the Snell's law particularly. That constant is nothing but the at the after the studies it is named as refractive index, and that is very important thing. In the next slide we discussed about it in the deeply. What is the mean of refractive index? Before that, I'm just completed out the what is they are explaining. The constant here, what is the constant written and how to symbolize the constant is n21. What does it mean that n21 is the refractive index of the medium 2 relative to the medium number 1. If it is n21, then it's a refractive index of the second medium to the 1. If it is n12, if it is n12, the refractive index of the medium number 1 respect to the second. In this way it will be called. Let us go for the now. What is exactly this constant? What is n? That n is named as refractive index. And what is the mean of refractive index? Refractive index is the index means number. Refractive index is the nothing but the numbers is which represent how much light can bend inside that medium particular. Suppose air has refractive index 1. What is the mean of 1? Why the air has a mean refractive index 1? Because when light is passes through the air, it is not deviating, so the refractive index is not deviating, so it is 1. So the water has a refractive index is 1.33. It means 1.3. So when light is entered into the water, it is band according 1.3 degree. This is little bit critical to you, but yes, you can go ahead. Glass has a refractive index 1.5, exactly 1.5. 1.52 also it can be in this particular glasses. So think about it. When light is passes through the water, it has 1.3 refractive index is band. Same light, same angle, now you are falling with the glass, it has refractive index 1.5, where light is band more. It is mean that high refractive index of the animediums is tells us the highly it will bend. So the refractive index is nothing but the index, it is number associated with the medium that can tells us about, it can give the information about the how much dense system it has, how much dent it has, how much light can flow there, and if how much light will bend. Okay, so this constants you can able to find with the velocities ratio. As I mentioned, the ratio of the velocity of the light in a first medium of the velocity of light in the second medium. See, it is a v1 and v2. If you take the respective n21, what is the mean of n21? The refractive index of the second medium to the one medium. So you have to take your velocity ratio like a velocity ratio like a v1 by v2, not a v2 by v1. When you are taking the v2 by v1, when you have n12. Okay, why I will tell you. Now suppose your first medium, which is air, there v1 it is a velocity of light is something, and when second medium is the water, and definitely this is air is the gas medium and the water is a liquid medium, so it's a little bit dense more. So the density more, it means the light is slow down. So what v1 exactly, suppose it is 100 km per hour, suppose for your example, then the in water v2 should be less than 100 definitely. Okay, it is understandable. Now suppose it is 50. When light is passes through the air, it has 100. This is worst of all example for your understanding. It is 100, and once it is passed through the water, it has a 50. So what is a v1? 100. And what is v2 for you? 50. So what is the ratio? 100 by 50 is a 2. So the n21, what is the n21? The refractive index of second system, second medium to the respect to the one, it is 2. What does it mean by that? The light is bending, more bending, it's bend in so band in such a way, so doubled. So trying to understand these things, it is a very important. By the velocity ratio you can able to make a judgment of the refractive index of the mediums. The refractive index of the transparent medium with the speed respect to the vacuum, it's known as the absolute refractive index. The n1 is the absolute refractive index of the medium number 1, n2 is the refractive index of the medium number 2, velocity of the v1 and the medium number 1, velocity of the particles in the medium number 2. What is n1? N1 is the absolute refractive index. Whenever you heard this word absolute refractive index, it means their first medium, your respect to the medium is space, because in a space we have a none of the medium we have. This is the no medium we are telling, vacuum. So their velocity, and to the respect to the another any kind of air, glass, water, diamond, any kind of medium you have, we are with respect to the space. This is the fundamental. So there v1 can be c, because the space of and the speed of light in a space we are tagged as a symbol as a c. C is the speed of light in a vacuum, which is always 3 into 10 to the power 8 meter per second, 3 lakh kilometer per second. So the refractive index of the first medium is C by V1. What is the C by V1? Is nothing but the velocity ratio. This is nothing but the V2 by V1 like structure. This is N2 is equal to C by V2. Now what is N21? N21 is equal to N2 by N1. And what is N2 by N1? What is N2? You know C by V2. What is N1? C by V1. You can cancel out CC. You will get V1 by V2. And that we already know, this is N21 is equal to V1 by V2. That is a proof of it. How you reaches to the N21 respective. This is the, when you are writing by the only N1, N1 is tells us the refractive index of that medium with respect to the space. If you are not writing N1 or anything another, n12, then 12 you are writing, it means you are making a that is your not absolute refractive index. When you are have n1 n2 like structure, that's the absolute refractive index likewise. Okay, so at the end I can say that constant, what the snell says tells, constant is nothing but the n21, and n21 is already nothing but the n1, n21 is equal to n2 by n1. So that constant is nothing but the n2 by n1 sine theta 1 upon sine theta 2. As already you seen, sine theta 1 by sine theta 2 is equal to constant, and constant is nothing but the refractive index of n21. N21 is equal to nothing but the n2 by n1, and just you are multiplying this n1 in this side, n2 in this side, so the n1 sine theta is equal to n2 sine theta, and that is nothing but the Snell's law fundamentally. Now what is the law of reflection? Why I am discussing at the law of reflection at the end of the discussion? It is not the end of the discussion. This is the now refractions of discussion start. The incident ray, refracted ray, and normals are the surface separating to two mediums at the point of incident, all lies in the same plane. That incident ray, refracting ray, normals, all are in a with the two mediums, but all are in a one plane. Yes, this is satisfying one plane. Second, the ratio of sine of angle of incident, the ratio of sine of incident angle, the sine of refracting angle is always constant. Always in such situations, the law of refraction they are following say remains a constant, and this is the law of the Snell's law of the refractions. What is the second rules? The ratio of sine of incident angle, sine of refracting angle is always constant, which is nothing but the refractive index of the respective mediums. It is nothing but the Snell's law. Thank you. Thank you very much. Is there any kind of difficulty you face in the discussion? You can comment on the respective site.